Students, coming to the next topic, that is the architecture of 8255. Now let us see what is this architecture. In the previous video I explained about the pin diagram of 8255, that is a programmable peripheral interface, so which consisting of the ports, port A, port B, port C. So these acts as an interfacing circuit between the peripheral devices and to the external world, to the 8086 microprocessor. Now let us see the architecture of 8255. So this architecture consisting of, let me first explain just the components that are present in 8255, and later we will discuss each component clearly. So this consisting of data bus buffer, which is having a bidirectional data bus, which is that is connected to the CPU. So this data bus buffer is connected to the CPU, which acts as a bidirectional. The data from CPU to 8255 and 8255 to CPU. Only the data will be transferred here. And now coming to the read or write control logic. This read-write control logic consisting of read signal, write signal, A1, A0, reset and chip selection. So here the read, it reads the data from 8255 to the CPU and write the data from CPU to 8255. A0, A1. So this indicates the port selection. So which port we have to be selected, either port A or port B or port C. So that will be decided based on these two address bits, A0 and A1, and the reset. So these are all connected to read-write control logic. Now coming to this. Actually, this 8255 is divided into two groups, Group A control and the Group B control. So the Group A control holds Group A port A and Group A port C upper. Okay, so this Group A holds port A and port C upper. Okay, so this is an internal bus. So internal bus consisting of data bus, address bus and control bus. So this is the internal bus. And here you have to be remember that Group A control holds Group A port 8 bits and Group A port C, port A and port C upper. And whereas Group B control holds port C lower and port B and port C lower. Group B port C lower, port B. Group A port A and group port C upper. So you have to be remember that upper port C and port A. This group B consisting of lower port C and port B. Okay, and here you are seeing that this is input output pins that is totally 8 pins are connected to the external devices. So you can take at a time you can take 8 bits of information. Okay, so and here also this is the 4 bits are connected to input output devices, and these are the 4 pins are connected to input output, and this is a total 8 pins. Now let us discuss each and every component clearly. The first we have to discuss about the data bus buffer. So what is this data bus buffer consisting of? Let me write that. So this architecture, this complete 8255 architecture is divided into 3 sections. Architecture is divided into 3 sections. So what are those? So first is data bus buffer. Next, read-write control logic. Read-write control logic, and the third one is Group A and Group B ports. Group A and Group B ports. So Group A consisting of port A and port C upper. Group B consisting of port B and port C lower. So now let us see what is this port data bus buffer. Data bus buffer. This data bus buffer is a it is a 3-state bidirectional 8-bit buffer. So data bus buffer is a 3-state bidirectional 8-bit buffer used to interface which is used to interface the 8255 to the system bus. It is used to interface the 8255 to the system, you call it a system data bus. So it's just connected to system data bus. So here the data is transmitted or received by the buffer upon execution of input or the instruction by the CPU. So whatever the instruction that the CPU is giving, based on that instruction, the data is transmitted or received. The data is transmitted or received based on the execution of the input or instruction given by the CPU. And here the control word and status informations are also transferred through the data bus buffer. So here the control word or status information is also transferred. So not only the data is transmitted or received, at the same time the control word or status information is also transferred. So this is about the data bus buffer. Now let us see what is this read-write logic. Let me explain this read-write logic. Read-write control logic. So what do we mean by this read-write? So the function of this block is to manage, the main thing is to manage all of the internal and external transfer of both data and control or status words. So the main thing we have to do in this 8255 to this CPU and CPU to 825 is we have to transfer data, control or status words. So these three we have to be transferred. So that will be controlled by this read or write control logic. So this function of this block is to manage. It is going to be manage all of the internal and external transfers that are going from 8255 to 8086 and 8086 to 8255. So which are consisting of data or control or status words that will be managed by this read-write control logic. Okay. So now let us see what is this A0 and A1. A0 and A1 port. So I said this A0 and A1, this is a port select 0 and a port select 1. So these input signals is conjunction with read and write chip. The first thing is this input signal is always conjunction with read write. So when to read and when to write and to which port we have to read and from which port we have to write, that will be decided by this A0 and A1 based on the chip selection. So this input signal conjunction with read and write input controls the selection of one of the three ports in this 8255. And they are normally connected to the least significant bits of address A0 and A1. So and the next is the chip selection. So we know that the chip selection. So these are all the pins connected that are present in the read-write logic. Okay. So these are present in read-write logic. The chip selection, a low on this input. I already explained this about in pin diagram. A low on this input pin enables the communication between the 8255 and CPU. So it is going to be enable the communication between 8255 and the CPU. That will be done by the chip selection. So in read-write control logic, you are having still RD bar and WR bar. So these are used for read and write. So the read, whenever a low on this pin enables 8255 to send the data or status information to the CPU. Okay, it is going to be send the data or status information to CPU. Whereas write signal from CPU to 8255. So read is 8255 to CPU, and whereas write is CPU to 8255. We are reading the data from 8255 to CPU, and write is performing the data is returning to the 8255. Okay, and the next component, next section is the group A and group B controllers. So that we will discuss in the next video. Thank you.